So good morning to everybody. I'm Seth Berman. I'm President and CEO of Instantiations. And thank you guys for coming today. We're really looking forward to it, and you're going to see it's a pretty exciting demo and technology platform. And I always look more forward to meeting folks, so please, afterwards, let's come say hello. We can talk a little bit. Just so you know a little bit about me, while I'm a CEO, sort of started my career as a software engineer. And that technical mindset carries through to today. I love coding, solving technical problems, and I've been doing that for a little more than 20 years at this point. And so while I really enjoy the challenges of being a CEO, I still kind of always jump back to working directly with technology when I can, because it's still kind of my primary passion. And I've always been very interested in ways specifically to sort of create a great development experience. One of the things I did was I spent a few years developing sort of a real-time type inference system for our product, the VA Smalltalk, that integrates with the developer tooling. So this is, it basically provides pretty much what would be the most sophisticated set of code completion and code analytics and sort of refactoring that you'll probably see for any dynamic language today. And in fact, Instantiations frequently focuses on sort of development experience improvement. So when we joined Riot in 2019, we kind of gravitated towards taking a closer look at the developer tooling for IoT specifically, sort of what programming languages people use, what are the tools, and kind of what we started to notice was certain things in the developer workflow, kind of like the deployment and testing and just basic development tools and debugging, seemed rather tedious and time-consuming, sort of from our perspective and where we were coming from. So we pretty quickly concluded that the IoT development experience could be better, and it should be better. So in other words, it should be more like programming, desktops or web applications. So I get that that's sort of easier said than done, but you really shouldn't have to go to a low-level language like assembly or C or C++ if you don't need to. And then the flip side of that is you shouldn't necessarily have to use non-performance slow languages like, say, Python or a MicroPython as well. And so thankfully, there has to be a better option, and kind of thankfully at this point there definitely is. So, and that leads me to our session today, which is taking IoT programming to a higher level. So whether it's a microcontroller or sort of a cloud instance, you shouldn't really have to resort to low-level languages or some sort of other language that isn't necessarily ideal as sort of your only option or your default option. And sort of, as you may have guessed by this title, Instantiations and Toit are going to talk about using higher-level language, a higher-level language platform for IoT development specifically. And what may surprise you is that using these high-level languages are still quite performant, as well as streamlining and improving sort of your development experience overall. So with that, I'd like to sort of introduce the presenters for today. You've sort of already heard about me a bit. We also have Casper Lund, who is the CEO and co-founder of Toit. I first heard of Casper years ago as an engineer at Instantiations with another team, a few team members. We were tasked with rewriting VA Smalltalk's platform, sort of the virtual machine, because we needed to upgrade it for 64-bit. And so for various technical reasons, this essentially required a complete rewrite from the ground up of the virtual machine. And so while me and the team were proficient in low-level coding, we sort of found ourselves needing to become virtual machine experts in a hurry. And so the team spent lots of time researching sort of all the classic techniques to use to make dynamic languages run performantly. And Google's V8 JavaScript engine that runs on their Google Chrome web browser ended up being a great source of inspiration for us, in a place that we learned a lot about these tricks. And as you'll hear, Casper was deeply involved from the ground up on that. In fact, he was the technical lead on V8 that basically changed the web forever. But you'll hear more about Casper and learn a bit more about his background. Also from Instantiations, we have Mariano Martinez-Peck, who's one of our senior engineers, and he's been with Instantiations for a few years at this point. And he's one of our engineering leads for IoT technology, and he'll be doing a really great hands-on demo for everybody today. So before we get too far, I'll do just sort of a brief introduction about Instantiations. We were founded in 1988 in Portland, Oregon. In the last 30 years, the company's kind of changed a lot, as you might imagine. Sort of within that time, we've had lots of mergers and spin-offs. We had a partial acquisition with Google in 2010. But fundamentally, it's the same company throughout the continuity of its founders, its sort of business focus, and our name during that time. And we've moved the operations from the West Coast to the East Coast, and so we're now headquartered here in Raleigh, North Carolina for the last 4 years. And our core focus is development tooling, which is mostly shown through our main product, which is the VAST platform. And so we'll talk more about that. VAST is a Smalltalk-based development environment that started its life as IBM Visual Age for Smalltalk. And we've since sort of taken over that product from IBM, rebranded it, and we have had yearly major releases of that for the last 15 years. And so unlike traditional IDE development, we're also improving, the VAST, we're also improving how the Smalltalk language itself runs by updating the language itself, the virtual machine, the tools that run it. In fact, recently, as I mentioned before, we redid the entire virtual machine. We added a just-in-time compiler to give good performance. And sort of as a reference point, VAST is faster than your standard Python version by many factors, about 5x, maybe a little bit more. And even faster than what IBM had originally done with the virtual machine back in the 90s. So to be clear, while we have expertise in Smalltalk, because that's what the VAST platform is, the skills needed to build up that require significant expertise with assembly, C, C++. Languages like Python and Dart and Rust and Java are all really familiar to us, and so that's where our technology services kind of come into play as a company. And so essentially we're offering our lessons learned and expertise that we've accumulated over the last 30 years to help solve kind of the toughest problems out there to give our customers kind of a competitive advantage. And so this usually comes in the form of custom development, training, and more recently, IoT-related development and consulting. So as you can imagine, we've worked with a variety of companies and individuals over the years, and our software and services are kind of leveraged by Fortune 100 and 500 companies, small and medium-sized businesses, and we even have quite a few solo developers and entrepreneurs that use our product. And you can see some of our kind of current customers on the right side of the slide there. Okay, so now that you know kind of a little bit more about us, let's move this thread back to the original, sort of taking IoT programming to a higher level, and answer the fundamental question of why is a higher level development experience better? And so I think we all sort of intuitively know why high level languages can be better. And while I'm sure this will be a review for many of you, let's just make sure we're sort of all on the same page on some points. So to be clear, the advantages we're listing here don't necessarily apply to all high-level languages, but certainly the ones we'll be highlighting today. So for example, high-level languages tend to deal with higher-level abstractions, objects, methods or functions. We talk about things in terms of message passing, various paradigms to help us think and reason about the programs that we're writing. A lot of studies done on productivity levels of writing systems in higher level versus lower level languages, so it should be no surprise that they're typically far more productive. There's definitely an aspect of memory safety and well-defined behavior that you get in higher level languages typically. And because of just that higher level abstraction, they're typically a lot easier to debug. Definitely languages like Smalltalk, we tend to have a live programming environment where you can sort of debug and execute and develop all at the same time. And as a high-level language, it tends to be a little more human readable because the concepts are kind of closer to you, the human, rather than the machine. And along these lines, Instantiations' VAST platform and Toit's language has some compelling advantages specifically that we're going to talk more about today. So kind of for starters, on the instantiation side of things, we already sort of mentioned the VAST platform. And for those looking for a more multi-purpose language, VAST is a great development environment experience because the IDE is already included and fully integrated with the Smalltalk language runtime. It works on Windows and Linux operating systems, as well as Intel and ARM-based processors. Can be installed in cloud instances, which many of our customers use, and works on devices kind of all the way down to the single board computer on the edge. And for those that haven't heard about Smalltalk, it was one of the first object-oriented languages that basically came out of Xerox PARC Palo Alto with a lot of great innovations. It's pioneered many concepts in modern software development, concepts like the integrated development environment itself, how an IDE came about, the model view controller paradigm, code refactoring, UIs in general, that all came out of Xerox, and as well as processes like test-driven development that came out of the Smalltalk community, and so it's had a lot of intellectual impact on the field of computing. And it's surprisingly productive language. We recently heard from a customer that when two teams were building equivalent systems in VAST and Java, it took the Smalltalk team 2 months to build it, and the Java team 9 months to build it. And these kinds of stories really aren't that unusual, and we hear them a lot from our customers. And sort of this level of productivity is kind of a huge differentiator for many of our customers. And from an execution speed standpoint, as I mentioned, it tends to be faster than, say, a Python or Ruby or some kind of scripty dynamic language. And this is kind of expected because VAST is very mature, has a very mature just-in-time compiler that will basically optimize out dynamically dispatched method calls to jump instructions, basically compile and link highly used parts of the program into native machine code, and it does that at runtime. And so it's sort of also important to note that VAST technology has been proven for about 30 years. So it's really stable, and it's why it's sort of relied on in a lot of enterprise, in the enterprise field. And it's a multi-purpose language. It's well suited for, say, orchestration for various technologies and database types. Plus, due to its lightweight packaging ability, it even runs well and deploys easily on edge devices. But, like most things, it can't be the choice for every situation. So we've sort of already spoken on several occasions at the Riot community about VAST. And so that's why we're kind of moving our focus for the majority of this talk to a new and exciting language that goes where VAST can't go. And so you've probably guessed where that is. Once this, let's see. There we go, I guess a little lag. One of the situations where we can't go is microcontrollers. And so while VAST can work in many environments, in AWS instances, and Raspberry Pis, it's still coupled to an operating system like Linux or Windows. And so that's kind of where Toit comes in. And so we're excited about Toit because it shares many similarities and strengths with what we have in the VAST platform. The way the language is constructed and kind of the approach that they take really complements our own and seems very, very familiar to us. So it's a language that we're excited about working with because it's so productive, and unlike anything we've experienced when working with microcontrollers in IoT development. And so this is where microcontroller development and IoT should be headed. So in short, going back to the theme of where the session started, it puts the development experience first, and while not neglecting the performance aspects as well. So kind of what makes it so special? Well, there are some pretty cool points, but who's behind this language? Toit is the company, Toit, the company, is comprised of software industry veterans and founded by Casper Lund and Lars Bach, who are responsible for the Chrome V8, among other cool technologies. But that's just a quick intro. For now, I'm gonna hand it off to Casper, and he's going to tell you, a much better story.